The topic that we are discussing is on gradient, the gradient and equations of straight line. That is actually the topic that we are handling at the moment. So in this particular Zoom session, I want to take an opportunity and maybe revise on the gradient part, which I've done through the videos. And then we connect now with the equation of a straight line, which should be now the focus of this particular lesson. Gradient, it is normally referred as the slopeness. It can be the slopeness or steepness of a line. And the key thing that you need to note is that we are referring only to straight lines here. We are not referring to any curve, or we are not actually referring to any particular quadratic kind of a curve. And for that case, we are talking about a line that is actually drawn using a ruler. Therefore, the gradient can either be positive or it can be negative, depending on how the line is sloping. If you have your graph paper or your Cartesian plane and you draw your line and then it slopes like that, the gradient is going to be positive. But if you draw your Cartesian plane and you find that your line is sloping like that, this is going to have a negative gradient. That is the starting point. Then you should be able to realize that gradient is obtained whenever you are given 2 points where the line is passing. If you are given the 2 points where the line is passing, the gradient will be given by change in y over change in x. So you can be told that a line, passes through these 2 points. So this is a straight line that has been drawn, and then it passes through those 2 points. We can call them point A and point B like that. Whereby point A, maybe we have got this point is 2, and at this point is maybe 6. That is on the x-axis. And then on the y-axis, this point here, it is maybe 4, and this one is maybe 7. You can be told, can you calculate the gradient of this line AB? One thing you need to note is this: the point A is given by the coordinates 2 on the x-axis and then 4. So we go 2 units from the origin, 2 units and then 4 units so that we can get to this point. For the point B, we shall go 6 units on x and 7 units on y. So the coordinates is given by 6, 7. Therefore, gradient is calculated as a change in y over change in x. When we talk about change, we simply mean that we subtract the y values or the y coordinates. Remember, this is the same as x1, y1. 2 is our x1, 4 is our y1. So this is actually our x1, this is our x2, this is our y1, and this is our y2. So one thing you'll be able to realize that change in y, we shall subtract the y coordinates. So this is our x2, y2. Therefore, change in y will be equal to y2 minus y1 over x2 minus x1. Point to note here is this: when we are talking about y2 minus y1, then on the change in x, we need also to have x2 minus x1. We cannot have y2 minus y1, but when we come here, we do x1 minus x2. If it is y2 minus y1, here it must be x2 minus x1. If we do y1 minus y2, here it must be x1 minus x2. They must have or follow that particular sequence. Therefore, our y2 is 7, so gradient will be given by 7, which is our y2, minus y1, which is 4, over x2, which is 6, minus x1, which is 2. You will find that this one is going to be 3 over 4. And that is your gradient for that particular line. That is the gradient for that particular line. It is simply given by the change in y over change in x. And then you are able to get it. So today, I want us now to connect this particular concept of finding the gradient so that now we can be able to know how do we get the equation of a line. So our focus for this lesson will be on determining the equation of a straight line. Equation of a straight line. I will start by saying this, that a straight line will have the equation in the form of y is equals to mx plus c. Y is equals to mx plus c, where this m will be referring to gradient, that is the gradient of that line, and this c will be referring to the y-intercept. The y-intercept, it is the point where the line is cutting the y-axis. So if you draw a line and maybe the line is cutting the y-axis at 4, then C is going to be 4 because it is now the point at which that line cuts the y-axis. And then M is going to be the gradient or the slopeness of this particular line. And note, whenever we are having a straight line, it is always constant. The gradient is always constant. Having said that, we can look at an example. We have an example here where you are asked, find the equation of the line, or let us start by this, find the gradient of the line, the gradient of the line that passes through points A, 1, 3, and B, 2, 8. You are told you find the gradient of that line. Simply note that this is going to be x1, y1. This is x2, y2. Therefore, gradient will be equal to y2 minus y1. So it is 8 minus 3 over x2 minus x1, which is 2 minus 1. You will find this one is going to be 5 over 1, which is actually 5. That is the gradient. That is the gradient for that particular line. You can be asked now, determine the equation of that line. You can be asked to determine the equation of that line. So if you are asked to determine the equation of the line, you need to express that equation in the form of y is equals to mx plus c. That equation should be in the form of y is equals to mx plus c. And note, I want to repeat here, anytime we are referring to straight lines, gradient is constant throughout that line. So if you have your line like this, the gradient at this point is the same as the gradient at that point is the same as the gradient at that point, because this line is actually straight. When you are told now to calculate the equation, you need to have two things. For you to be able to calculate the gradient, you need to have two things. One, you need to have the gradient. Then 2, you need to have the at least 1 point. At least 1 point through which that line passes. So in this case, we are already sorted. We have the gradient is 5. At least we have 1 point. So we have got point A and point B whose coordinates are given, so we can choose any. So at this point, we are able to calculate this gradient and say here, if we have got, let us use point A. If we have got point A where the line passes, which is given by 1, 3, and we assume now another point, it also passes through the point XY. Remember, this straight line has got so many points it passes through. We assume another, you take one that is known, you assume one that is not known. It passes through 1, 3, and another one XY. Therefore, because it's a straight line, whichever 2 points we are going to take and do change in y over change in x, they should give us the same gradient. So we need to come here and say, therefore, y minus 3, which is now our y2 minus y1 over x minus 1, they should give us the same 5, which is the same as 5 over 1. If you cross multiply this, 1 to multiply here and 5 to multiply here, we are going to have this y minus 3 times 1 is equals to 5 into x minus 1. So this 1 will multiply here, this 5 will multiply here. Therefore, y minus 3 is equals to, if you open a bracket here, is going to be 5x minus 5. Let us take this 3 to the other side so that we remain with y on this side is equal to 5x, and then we are going to have this 3 coming to this side to be positive, so we are going to have minus 5 plus 3. So y would be equal to 5x minus 2, because minus 5 plus 3 is actually minus 2. And this is actually the equation for that particular straight line. Note the procedure. Procedure number 1, you get the gradient. After getting the gradient, take one of the points that you are given and assume another point. And the point that you assume, you say that the other point where that line passes through is given by the coordinates xy. So if I do change in y over change in x, using these two, they should give me the same gradient, because the gradient of a straight line is always constant or the same throughout. So it does not matter which 2 points that you are going to use. If I use these two and I use these two, they should give me the same gradient. So you do change in y over change in x, and then you equate here with the gradient that you had calculated, because they are supposed to give you the same gradient. And then now you cross multiply to get that equation in the form of y is equals to mx plus c. Let us try another one. Let us try another one. You are told that a straight line passes through the point 0, 4, and then another point negative 2. It's actually negative 1, negative 2. It also passes through a point negative 1, negative 2, like that. You are told find the equation. Find the equation. Anytime you are told to find the equation, you cannot do it without first of all getting the gradient. There's no way you can find the equation without the gradient. So if you do the change in y over change in x, we take this one as our y2, this is our y1, then it's going to be negative 2 minus 4 over x2 minus x1, negative 1 minus 0. You will find that the gradient will give us negative 6 over negative 1, which is actually 6 for that case. After getting the gradient, we take 1 point of the 2 that we are given, which is 0, 4, and another one we assume, which is xy, like that. And we say this, if we do change in y over change in x, using these two, they should give us this answer. Therefore, y minus 4, which is now change in y, over x minus 0, they should give us the same 6, which is the same as 6 over 1. If you cross multiply there, 1 will multiply here and it will have no effect. So it is going to be y minus 4 is equals to 6 into bracket x, because x minus 0 is just x. Therefore, y minus 4 is equals to 6x. Let us take negative 4 to the other side. So y would be equal to 6x plus 4. And that is your equation. The point I want to emphasize is this. We said the equation of a line is given by y is equals to mx plus c, where this value that is next to x is the gradient, and this one, it is the y-intercept. So the value that you are going to get next to x here should always be the same as the gradient that you obtained. Like, for example, here, y is equals to 6x plus 4. Therefore, our m, which is the gradient, is 6. And actually, that is what we got here. So the gradient that you found here is going to be the number that is going to be adjacent to x. Then you add plus 4. And plus 4, in this case, it is the y-intercept. Okay, maybe we can try one more before we go to something else. You can be given 2 points like this. You are given 11.1 and 14.4. These are the 2 points that you are given through which the line passes. If this is the case now, you are told to find the equation. Start by finding the gradient first, which will be changed in y. So it is 4 minus 1 over change in x, which is 14 minus 11. You will find this one is going to be 3 over negative 3, which is actually negative 1. So the gradient is negative 1. Then take 1 point, 1, 11, 1, and you assume, and when you are assuming, you always assume xy. If we do change in y, so it is y minus 1 over x minus 11, they should give us the same gradient that we calculated here, which is negative 1 over 1. Do change in y, you do the cross multiplication, which is y minus 1, because if you multiply by 1, it will not have any effect, is equals to negative 1 into x minus 11. Therefore, y minus 1 will be equal to negative 1 times x is the same as negative 1x or negative x. Negative and negative is going to be plus 11. Then you will find that if we take negative 1 to the other side, we shall remain with y is equals to negative x plus 11 plus 1, which is the same as y is equals to negative x plus 12. And you can be able to note here we have negative 1x, which is the same as the negative 1 that we found here for the gradient, because actually our m here, our m is actually negative 1 because of this negative. It is the same as negative 1x. That is actually what we are referring as. Anytime you are told to get the equation of a straight line, always start by getting the gradient. Always start by getting the gradient and then assume 1 point, and then you should be able to get that particular equation. I want us to see another approach that you can be told to get the equation. You can be told this, that a line has a gradient. A line has a gradient of negative 2, and it passes through the point 7.2. Now you are told, find its equation. Find its equation. So in this case, you have been given actually an opportunity to move or to do away with the first step. Already you have been given the gradient, so you don't need to calculate the gradient, and you have been given at least 1 point. So gradient has been provided as a -2, and you have been given 1 point, which is 7, 2. Therefore, it is just a matter of assuming another point x, y, so that you have 2 points. And then you do change in y over change in x. They should give you this particular gradient. So y minus 2 over x minus 7, they should give us the -2, which is the same as -2 over 1. Cross multiply, 1 to multiply here. So it is going to be 1 times y minus 2, which is the same as y minus 2, should be equal to -2 to multiply this. So we shall have -2 into bracket x minus 7. Just a minute, please. Sorry. I was using my phone, and I was using my phone as the internet, as the source of internet, and the caller has interrupted it. But we can finish this question. So if you cross multiply, you get this. Therefore, if you open the bracket on the other side, you are going to find that y minus 2 is equals to -2x. Negative and negative will be positive. 2 times 7 is 14. Therefore, y will be equal to -2x plus 14 plus 2. So this one, if you add it, is going to be 16. So it's the same as y is equals to -2x plus 16. And you should be able to note that the -2 that we have here is the same as the -2 that we had for the gradient. And by so doing, you get your answer as simple as that. I want you to try this. Try this where you are given the line. Somebody needs to mute the mic. You are given this, that the line passes through points given, or let me put it this way. The line passes through point 25 and has a gradient of 4. The thing is now find its equation. I want you to try that, and if you are able to do it, then you are sorted. The line passes through point 25 and has the gradient of 4. Find its equation. So can you try that? And then I'm going to go off for 10 minutes. To try that, and then I will be off for 10 minutes, and then I will come in so that we can do another part. At exactly 3:40, I will be back, so that we can be able to look on another concept. But meanwhile, try this.